Hello and welcome to another tutorial session on my YouTube channel. We continue with presentation for the Northwest Regional Mock 2020 Further Mathematics Advanced Level. The question reads, express 2x plus 3 divided by x plus 1 all squared into x plus 2 all squared into partial fractions. Hence, show that the summation of what you are seeing here is equal to this. So let's get into the solution without wasting much time. We have um, that this our expression. We have to express this fraction, this algebraic fraction, into partial fractions. So we have to recognize that the degree of the numerator is 1 and that for the denominator is 4. So this is a proper fraction and it has repeated factors. So we are going to have the general partial fraction expansion in the form we have a over the first factor plus b over the second factor over the same factor now all squared. When you have the case of repeated factor, you range the power from from 1 up to that power. So since the power is 2, I start from 1 plus x to the power 1, go to the next s plus 1 to the power 2. Once I arrive at the power of that factor, I stop. I do same for the other factor since it's repeated. It is a repeated linear factor. So on any above each of the term, we'll be having what? A constant. Every linear factor decomposed to a constant at the numerator. Because when you're doing partial fraction, the goal is that the degree of the numerator of any of the fraction that you get should be less than that of the denominator. So since here is a linear factor, then we should likely have a constant there. That's a term x to the power 0. Good. With that now, multiply all through by the denominator of this left hand side. That's x plus 1 squared into x plus 2 squared. We are going to have a into, when we multiply a by this denominator, one of the x plus 1 will cancel out, leaving out just 1, x plus 1 to the power 1, and the other part just remains the same. And when we multiply here, the term in x plus 1 cancels out completely, leaving out what? S plus 2, all that squared. And the term in c, when we multiply here this fraction by this denominator, the term in s plus 1 squared remains, while that for x plus 2 all squared, the power reduces now by 1 because one of the factor will cancel out, and you have that as you can see, and the other part follows. So the other term cancels out completely. That's s plus 2 cancels out completely. From this now, you have to know that the goal now is for us to look for what? A, B, C, and D. Don't waste your time expanding this whole bunch in front of you, because it will just give you a mess up and you get confused at some spot. Even though if you do it like that, you still have the answer, but it will quite be long. Once you have a linear factor like this, I have two linear factors involved here, which means that I am obliged to get two constants without doing much calculation. Look at this. This linear factor is squared, and I go to the right hand side, I look at the factor that is also squared, the linear factor that is x plus 1 and is raised to the power 2. Since that is a factor that was given in the equation, then means that I can get the constant b using the cover-up method. You know that this denominator vanishes when x is negative 1. So I will come here and use the cover-up method. I cover this term x plus 1 squared. When I cover that up, I'll be left with what? 2x plus 3 divided by what? X plus 2 all squared. And I'll replace now x equals negative 1. Since that's the term, the value of x that makes this denominator to vanish, I'll get b directly. So doing that, I have b equals to what? 2 into negative 1 plus 3 divided by what? Negative 1 plus 2, all that squared. And when you simplify this one, negative 2 plus 3 is 1, and negative 1 plus 2 is 1. 1 square is 1. 1 divided by 1 gives 1. And similarly, I come to the right hand side again. The term that has this factor s plus 2 all squared, the numerator, I look at the numerator, that's the constant I'm going to find if I use the cover method. So this denominator vanishes when x is equals to negative 2. So I come here now, I cover this term s plus 2 all that squared. I'll be left with 2x plus 3 divided by s plus 1 all that squared. So I just replace there by what? I'll replace that by what? Replace x there by negative 2, since it's a value of x that makes this denominator to vanish. I'm going to look for z directly. So my z will be equals to what? 2 into negative 2 plus 3 divided by what? Negative 2 plus 1 all that squared. And when you simplify all of this, we have negative 4 plus 3, that's negative 1. Negative 2 plus 1 is 1. And negative 1, when you square it becomes positive 1. So you have negative 1 divided by positive 1 giving us negative 1. So you see how cool it is. Now with that, now the next thing we have to do, since we have b and z directly already, this we are left with what? C and a and c, right? Now coming here, you will equate coefficients. We can now equate coefficient, or you can substitute values of x, several values. This is an identity. It means that whatever value of x we take and put here and also put here, left hand side will also be equal to the right hand side. Now without wasting much time, let me take the highest degree of the right hand side. When I expand this thing here, this is a quadratic, a linear factor. So when I expand this thing, it will give me something s cubed, right? So I can equate the coefficient of s cubed. Similar thing here, I can have a term in s cubed. Let me start equating the power starting from the highest, because it will save me a lot. Equating coefficients of s cubed gives us what? We just have a as a coefficient of s cubed here when you expand, because you can see that clearly here we have 1, we also have 1 here for this one, right? Also here, this is a quadratic multiplying a linear factor. The coefficients of each of the x here is 1 1. So basically when I expand this thing here, we just have what? Something x cubed, and the coefficient will be 1 times this c now will give us c. So the sum of the coefficient of s cubed on the right hand side is a plus c, and that will give us the sum of the coefficients here of s cubed, which is 0, as you can see. Now that's the first equation. Now I can now substitute 0. You can do anything here at this point. Substituting 0 in the equation gives us the following. When you put 0 here, you are left with 3 on the right hand side. When you put 0 here, it will give 1. 0 here, 2 square, 4. That's 4a. When you put 0 here, you have 4b's. When you put 0 here, 0 here, you get 2 times 1, right? That will be what? 2c's. And here where you put 0 here, we just have 1 square, which is 1 times z, and it's equals to what you have on the left hand side. When you put 0 here, you have 3. Now since we have b and z already, I substitute b equals 1 and z equals minus 1. When I do that, I have 4a plus a, since b is 1, plus 2c minus 1 equals to 3. And simplifying that gives us 2a plus c equals to 0, equation 2. Solving equation 1 and 2 simultaneously, you can see clearly that if I subtract equation 2 minus equation 1, I have what? A equals to what? 0. Solving equation 1 and equation 2 will give us a equals to 0. Since a plus c is 0, and it means that c must also be 0. You can see clearly. Now since a is 0, means that this guy here does not exist. C is also 0, this guy does not exist. So the final answer will just be what? This b over x plus 1 square, which is 1, as you can see, minus this one, as you can see, 1 on that, right? So that's what we actually have as a partial fraction decomposition of this algebraic fraction. So you look at how easy it is, right? It's always good to use tricks to answer such questions. Don't waste your time expanding all of this and comparing all the coefficients. You will just have a lot of constants. You have 4 constants there. You start substituting. At one point you go and make some sort of errors that I don't know. And it's always good that when you are done solving, it's always good to ensure this. You can just take quick values of x that you have not used while you were solving and replace here, and also replace here. Simplify both sides and see if the answers are the same. So now that is the answer for the first part of the equation. Let's look at the second part. Now we have to show that the summation of this series, as you can see here, that's the series, this is equals to this. We have to recognize that this thing here, this factor here, we can factor out it. When we do that, we are going to get, that can be factored out. When you factor out it, you have 2r plus 3 divided by this, and it can, a constant, it can just come out with a summation sign. And you have to know that this fraction here is exactly what we did as a partial fraction decomposition in the first part, except that x is replaced with arrow. It's exactly the same thing. The x there is just a dummy variable, so it does not change anything. It can be replaced with anything. Now, having this in mind, now we are going to call this is a general term of this series, right? The general term u sub r is equals to this. So all the other terms are generated using this. Since that this thing is exactly the partial fraction that we did, where x is replaced with r, we just come and copy and paste here. Now I'll write down all the terms of the sequence of this general term of this series. We'll write down the individual terms, then I'll add them together. We have the first term, u1. Remember the series start from r equals to 1. So u1 means I replace r by 1. When I replace r by 1 here, we'll be having 1 divided by 1 plus 1 all squared. That will be 1 over 4. Minus, when we put 1 here, we'll have what? 3 squared, that's 9. u2, you replace r by 2. You'll be having 2 plus 1, that's 3 squared, 9. Minus, we have
2 o'clock.
we put 2 here, we have 2 plus 2, that's 4. 4 squared gives us 16. And the other part, u3 will be equals to what? You replace r by 3 in this same relation. Because it's a general term, all the terms will be generated using this. When you put this, please don't simplify. We are heading to somewhere. When you put this, you have what? 4, right? 3 plus 1, that's 4 square 16. When you put there 3 plus that, 5 square 25, and that gives us that. We continue the process like that until we get to some point where we are at almost getting to the power when r equals to n. So before we get to n, we must pass through n minus 1, right? So u sub n minus 1 replace r by n minus 1 in this form. So n minus 1 plus 1 is n, that's squared, minus n minus 1 plus 2 is what? N plus 1 square. Now we go ahead again and replace. Now finally, when we find un is exactly replacing r by n, because we are summing from what? R equals to 1 to n. That's what we have. Now our sum, when we sum u1 plus u2 plus u3 plus all the way up to un, we are going to get this. Reason because this is a telescoping series. You see that when you add this plus this term cancels like this. It will keep cancelling in this manner, in that direction, as you are seeing like that, leaving out just this first term there and this last term minus 1 on n plus 2, all that squared. Now that's what we have. We go ahead and simplify that using subtraction of the fractions. That will give us n plus 2 square minus 4 divided by 4 into n plus 2, all that square. When you simplify these two, subtract these two fractions. Now this is just a quadratic. We can expand that, giving us n squared plus 2n plus 4 minus 4 divided by what you have at the denominator there. Now the 4 minus the 4 goes away, leaving out n squared plus 2n, which you have there. Now we stop at this point. Now we go back to our series. We can see that n can be factored out here. N is a common factor, so n, when you factor out n here, you divide each of these terms by n squared divided by n will give us n. 2n divided by n is 2. That's what we have. So our series sum, this series now, remember u1 u2 u3 is just the sum of this series, and we have to look for the sum of this series here. So the sum of this series is 8 times the sum of this one. So let's go ahead and do that. So this one will just be what? 8 times this value, right? And finally, when we do this, 8 divided by 2 will just give us 2. And finally, that's the proof that was given to us as required. So that's the end of the tutorial. Please, if you have not subscribed to this channel, kindly hit the subscribe button and don't forget to turn on the notification bell. Please share this video so that it can go viral, so that your friends can also benefit. Don't be selfish. See you guys in the next tutorial. Bye bye. Stay tuned. I love you all.